notice, and this is a typical copyright. We continue mathematics syllabus for CSEC for the years 2018 to 2027. Schedule of videos. I had hoped to finish all 33 videos from number theory and computation by the end of September 2024. I am somewhat behind schedule. As of now, I still have one more video to do after I finish the one I'm currently doing. By the end of October 2024, I should have the 13 to 15 videos from consumer arithmetic ready. And then November 2024, sets, December 2024, measurements, January 2025, statistics, February 2025, algebra, March 2025, relations, functions, and graphs, April 2025, geometry and trigonometry, and by May 2025, hopefully by mid-May 2025, vectors and matrices, and that will take care of all the objectives in this syllabus. As I pointed out, I have divided section 1 into 33 videos, all of which will be made available on YouTube in their entirety. This section forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will be able to do with the rest of the syllabus. So please look at all 33 videos and then decide if you will continue with the syllabus. And by the way, from Form 1 to Form 3 in secondary school, they also should be able to do this course section very well. As already pointed out, these 16 videos have been completed and published, and up to 31, that is to say 15 more videos have been completed and published. So that would be, of course, 31 videos from this section. Right now, I am doing video 32, more on number sequence, which means that we did some of that before. And after that, we have one more video to do, ratio and proportion, but we did most of that already when we were doing this objective, compare quantities using ratio, proportion, and rates. That was video 30. So this one and the next one would be mainly like repeating what we already did before. Maybe one or two new things, but most of it you would have already seen in previous videos. So objective 16, compute terms of a sequence given a rule. And then objective 17 says that you are to derive an appropriate rule given the terms of a sequence. So 17 would be much more difficult than 16. But we did some of that already in a previous video, as a matter of fact, the 4th video in this series. So basically, we did objective 17 already when we did video 4 from objective 1 in this same section 1. And objective 16 is even easier than objective 17, since we are given the rule and we have to supply the terms. So recall, and we are going back to video 4, objective 1, in this same section, when we talked about sequence of numbers that have a recognizable pattern. We divided that objective 1 into 4 videos, and the 4th one was this. So let's review what we already know from that video because some of you may not have seen it, may have forgotten it. So let's review that. Some very easy ones, and these are called arithmetic patterns. The sequences are based on addition or subtraction of difference between terms. So if you look at this, example 1, 1, 2, 3, 4, 5, even a grade, one child will tell you that the next 3 terms will be 6, 7, and 8. But they may not know why. It's just that they learn to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you look at this carefully, you would see from 1 to 2, you plus 1. From 2 to 3, you plus 1. From 3 to 4, you plus 1, and so on. And that is the rule that we are following here to make this one here 6, and this one 7, and this one here 8. That was an extremely simple example to illustrate the rule that we use. In example 2, 2, 4, 6, 8, 10, and yes, this is also very simple. From 2 to 4, you add 2. From 4 to 6, you add 2, and so on and so on. So you will keep adding 2 to get 12 here, and then 14 here, and then 16 here. Example 3, 3, 6, 9, 12. Now, it is going to get a little harder. Well, remember I said these are the easy ones. So from 3 to 6, you add 3. From 6 to 9, you add 3. From 9 to 12, you add 3. So you follow that trend, add 3 and add 3 and add 3. And so you get 15 here, and 3 would give you 18, and 3 would give you 21. Next one, example 4, 7, 14, 21, 28. So we add 7 to get 14, and then we add 7 more to 14 to get 21, and we add 7 to 21 to get 28. So obviously we will keep adding 7s. So this will be 35, that will be 42, and this will be 49. Example 5, remember I said these are the easy ones. 25, 20, 15, 10. So what did you do to 25 to go to 20? You subtract 5. And from 20 to 15, you subtract 5. And from 15 to 10, you subtract 5. Now these are rules that we developed and then applied. So this next term here, you will subtract 5. And the next term, you will subtract 5. And the next term, you will subtract 5. So this will be 5, this will be 0, and this will be negative 5. So those are the simple ones. Here we had to find the rule and add some more terms in the sequence. But the objective we will be looking at, objective 16, we will be given a rule and we have to add some terms. And then objective 17, we will not be required to find any terms, but we will be required to derive the rule. Okay, those were the easy ones. Then we looked at intermediate level, not too difficult, but not too easy either. So these follow a geometric pattern where the sequences are based on multiplication or division of the previous terms. So example 6, 1, 2, 4, 8, 16. What did we do with 1 to get 2, and what did we do with that 2 to get 4, and so on? So if you multiply 1 by 2, we will get 2. Multiply 2 by 2, we will get 4. Multiply 4 by 2, we get 8, and so on. So obviously, you will keep going that way, multiplying by 2. And so this next term here will be 32. The next one will be 64. The next one will be 128. Next, example 7. 1, 2, 3, 5, 8, 30. Now, let's see. what did we do with 1 to get 2, and can we do that same thing with 2 to get 3, and can we do that same thing with 3 to get 5? So we look for a pattern. In this case, we add the two previous numbers. Now, this is kind of difficult to come up with that rule. So if you add 1 and 2, you will get 3. And if you add 2 and 3, you will get 5, and so on. So here we will add those two, and we will get 21. And then we will add 13 and 21 to get this one here, which would give us 34. And then we will add 21 and 34 to get this last term here, which will give us 55. Okay, that one was admittedly fairly difficult. Example 8. 1, half, quarter, 1/8. From 1 to half and from half to quarter, what did we do? We divide by 2, and then we divide by 2, and then we divide by 2. So we will keep dividing by 2. Divide 1/8 by 2, you get 1/16. And you divide 1/16 by 2, you get 1/32. Next, example 9. 12, 16, 14, 18, 16. Oh, so this doesn't seem to, we don't seem to have a pattern. Let's try addition. 12 plus 4 would give you 16. But from 16 to 14, looks like we subtracted 2. Subtracted 2. And then from 14 to 18, looks like we added 4 again. And from 18 to 16, like we subtracted 2 again. So, plus 4 minus 2 plus 4 minus 2, let's follow that trend. Plus 4 minus 2. So 16 and 4 would give us 20. 20 minus 2 would give us 18. That one wasn't too difficult after all. So here we also had to find the rule and add some more terms in the sequence. Now, here were some difficult ones that we looked at already. This is example 10. 2, 3, 5, 7, 11. Now, remember I said these are difficult ones. And how is a number related to the one on its right? And that one on the right to that one on its right, and so on. Find a rule. In this case, from 2 to 3 is 1, from 3 to 5 is 2, from 5 to 7 is 2, from 7 to 11 is 4. You have a rule here. Actually, they are all prime numbers. So 2, 3, 5, 7, 11, the next three prime numbers are 13, 17, and 19. Next one, 11. 4, 9, 16, 25, 36. I did say that these were difficult, but you would have seen those numbers before. They are actually square numbers. So this 4 is the square of 2, that 9 is the square of 3, this 16 is the square of 4, that 25 is the square of 5. So 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. This, of course, must be 7 squared, which would be 49, 8 squared, which would be 64, and 9 squared, which would be 81. Example 12, 1, 3, 7, 15, 31. All right. So it looks, let's see. We can add 2 here to get 3. We could add 4 there to get 7. We could add 8 there to get 15. We could add 16 to get 31. All right, let's see if we have a rule. Add 2, add 4, add 8, add 16. So we should add 32 next, and then add 64 next, and then add 128 next. So we get 63, and 64 would give us 127, plus 128 would give us 255. Or you multiply the previous number by 2 and add 1. That will work too. Example 13. 1, 2, 6, 24. Now this one is extremely difficult. To move from 2 to 6, multiply 2 by 2 and add 2, you get 6. Let's see. And from 6 to 24, multiply 6 by 3 and add 6, you get 24. And from 1 to 2, multiply 1 by 1 and add 1, and you get 2. Here we seem to have a rule there. Multiply the previous number by 1 and then by 2 and then by 3 and add the previous number to it. So multiply 24 by 4 and add 24. So this will give us 120. And then multiply 120 by 5 and add 120. Multiply 120 by 5 and add 120, and we get 720. Okay, that one was difficult. Here we have to find a rule and add some more terms in the sequence. But remember, objective 16, you will be given a rule. Now, if you find this video useful and interesting, please like and share. That is to say, like and share. And if possible, you may also consider subscribing to this channel. As I said before, it doesn't cost you anything, and it means a lot to me. All right, so let's get back to objective 16. Compute terms of a sequence given a rule. Now you're given the rule, okay, and then objective 17, derive an appropriate rule given terms of a sequence. So in that review that we just did, we have done more than what is required by these two objectives. Nevertheless, just to be sure, we will separate them and do them over one at a time. So we will do objective 16 first, then we'll do objective 17 next, even though the review that we just did encompassed those two. The following numbers follow a sequence in which the rule is y plus 2 multiplied by 3, where y is the previous term. Fill in the two missing terms. So you have 2, 12, 42. So you take the previous term, add it to 2, that will give you 4 multiplied by 3, you get 12. Take 12, add 2 to it, you're going to get 14. Multiply by 3, you get 42, okay. So you take 42, add 2, and then multiply by 3. So that would be 44 multiplied by 3, you get 132. You take 132, add 2, multiply by 3, you will get that. And now we will take 402, add 2, and multiply by 3, and we get 1,212. This is the computer generated. So we began with 2, we got 12, then 42, then 132, then 402, then 12, 12, and if you have to go further, you will continue that sequence, and so on. Example 2. The following numbers follow a sequence in which the rule is y squared minus y being the previous term. Fill in the two missing terms. So we have 3, then 30, then this number here. So if it's 3, we are going to square 3 and subtract 3 from the answer. So 3 3 is 9, 3 3 is 9, minus 3, and we get 6. If we square 30, we will get 900 minus 30, and we get 870, and so on. The computer generated results are, if we began with 3, we will get 6, which is what we got over here. And after 6, the next thing we get would be 30, and then 870. And if we have to go further, the one they gave us there is 756,030, and so on. We actually move over into exponent because the numbers are so big they can't fit in these cells. That was 2. Example 3. The following numbers follow a sequence in which the rule is y multiplied by 3 plus 7. Y being the previous term, fill in the missing terms. So 5 multiplied by 3 would give you 15 plus 7 is 22. 22 multiplied by 3 would give you 66 plus 7 is 73. And 73 multiplied by 3, and then you add 7, you get 226. And 226 multiplied by 3, and then you add 7, and you get 685. So this is a Excel generated table. We started out with 5. We multiply it by 3, and then we add 7, and that gives us 22, which is what was given there. We do the same thing. We get 73, and then we get 226, which is that, and we get 685, which is this, and we had to go any further. We follow the same pattern. Example 4. The following numbers follow a sequence in which the rule is y multiplied by 2 minus 3, y being the previous term. Fill in the missing terms. So now we have 2 terms on the right and 1 on the left. So let's deal with the 2 terms on the right first. So if we take 5 and we multiply by 2, we get 10, minus 3, we get 7. Okay. 7 multiplied by 2, we get 14, minus 3, we get 11. 11 multiplied by 2 is 22 minus 3, we get 19. So what do you do for this one here? You can't follow the same rule because it wouldn't work. We don't have a previous term. So this is the computer-generated table. Actually, the previous term is 4. You can guess that, but there is a way of finding it without guessing. So we have 5, 7, 11, 19. The next one would have been 35, and so on. So that rule that we have up here is applied when you are moving from left to right. You're going in that direction. But if you have to move from right to left, going in the opposite direction, okay, this is what you do. You do the converse of what you did up there in the reverse order. So up here, we were multiplying by 2 first, and then subtracting 3. What we will do now to this 5 is we will add 3 and then divide by 2 to get this term here. So 5 plus 3 would give us 8, divided by 2 would give us 4. So we can put 4 in there from the computer, which is the answer we got when we did it on the computer. Example 5. The following numbers follow a sequence in which the rule is y divide by 2 plus 3. That would give you the next term using the previous term, y being the previous term. So we have a term to fill in here to begin with. We have 2, 4, and 5. So if we divide 2 by 2, we will get 1, and we add 3, we will get 4. Divide 4 by 2, we will get 2, and we add 3, we will get 5. Divide 5 by 2, we will get 2.5, and we add 3, we will get 5.5, 5.5. So here is a computer-generated answers. We began with 2, then we get 4, we get 5, 5.5, 5.75. We don't seem to be able to, we seem to be approaching 6, and the answer does not seem like it would pass 6. Okay, never mind that. Let's go back this way. Remember what I said, if you move from left to right, you will do the converse in the reverse order. So up here, you are dividing by 2 first, and then you are adding 3. Now, we will subtract 3 first, and then we will multiply by 2 to the number that is on the right to get the one on the left. So if we take 2, Subtract 3, we will get minus 1 or negative 1. Multiply that by 2, we will get negative 2, which is this answer here, which is the one we got here using the computer. But you don't have a computer to use if you are doing paper 1 in exam. So you have to work it out. So I think we have had enough of that. Given the rule, find the following terms or the previous terms. Now we go to objective 17. Derive an appropriate rule given the terms of a sequence. We'll just look at 3 or so because we looked at a whole bunch of them already. So example 1, consider the terms in the sequence below and deduce the rule used to get the term on the right of another term. Okay, here's the sequence. 1, 2, 4, 7, 11, 16. We have to deduce the rule. We don't have to get any more terms, just deduce the rules. So if we put it in a table, from 1 to 2, you add 1, and then you get 2, and then you add 2 to that 2, and you get 4, and then you add 3 to that 4, and you get 7, and you add 4 to that 7, and you get 11, and you add 5, and you get 16. So it seems like we are adding these numbers in sequence from 1, 2, 3, 4, 5. So the rule, so let's see. For the second term, you add 1. For the third term, you add 2. For the fourth term, you add 3. Look at these numbers. Fourth term, you add 3. Third term, you add 2. Second term, you add 1. And for the fifth term, you add 4. So it seems like for the nth term, you will add n minus 1 to the previous term. That is the rule we came up with. Look at it again and see if you think that's fine. Next one, example 2. We will consider the sequence below and deduce a rule to get the term on the right. Now remember, if we could get the term on the right, we will do the converse in reverse order to get the terms on the left. So 1, 3, 7, 15, 31, 63, let's put that in the table. So from 1 to 3, you add 2. And from 3 to 7, you add 4. And from 7 to 15, you add 8. And from 15 to 31, you add 16. And from 31 to 63, you add 32. So it's look like you're doubling these numbers beginning at 2 and adding them. That's one way. Or you multiply the previous number by 2 and add 1. This here looks actually easier to state a rule. For the second term, we got 2 and so on. Fourth term, we got 8. So it looks like you multiply the term on the left by 2 and then add 1. That seems easier than to derive a rule from this 2, 4, 8, 16, 32, though you could derive a rule if you want to. But this rule here seems easier. Example 3. Again, we would consider these terms and try to derive a rule to get the term on the right of another term. So from 1 to 3, what rule was used? From 3 to 9, from 9 to 27, and so on. So we write down the numbers. As you look at this, you could see that this first term is 3 to the 0 power, which is 1. 3, the second term is 3 to the first power. 9 is 3 to the second power. 27 is 3 to the third power. And so this looks like the place value in the base 3 number system, but in reverse order. In other words, this one should have been on the far right, and so on. So it looks like the place value of base 3 in reverse order. So place values in the base 3 number system in reverse order. In other words, we should have started with 1 on the right, then 3, then 9, then 27, then 81. This here being 3 to the 0, 3 to the first power, 3 to the second power, 3 to the third power, 3 to the fourth power, and so on. Those are the place values in base 3. As you can see, deriving a rule is more difficult, much more difficult than using one that is given to get some additional terms. So we looked at objective 16, compute terms of a sequence given a rule, and then we looked at objective 17, derive an appropriate rule given the terms of a sequence. And that brings us to the end of these two objectives. These two, objectives 16 and 17 in section 1.